Hello everyone, welcome back to our channel. In today's session, we will explore how to set up an AWS site-to-site VPN using Terraform, which will enable secure and seamless communication between on-premises network and AWS cloud resources. So these are the table of contents which we are going to learn today. So there are some prerequisites you should need to follow before you begin with this tutorial. So first is to have AWS account, then you should install Terraform extension in Visual Studio Code. So we will first learn about what is Terraform, what is AWS site-to-site VPN, then we will see components of VPN and the architecture of site-to-site VPN. Then we will see steps for setting up AWS site-to-site VPN using Terraform, which include steps like to create provider.tf file, create VPC in both the region. Then we will launch an Amazon Linux machine in North Virginia region, and then we will apply this configuration by using Terraform commands. Then we will create site-to-site VPN connection. Then we will apply the configuration again, and then we will access the EC2 instance launched in the North Virginia region by using mobextub tool. Then we will verify the tunnel status on our AWS console. And finally, we will delete all the resources, followed by the conclusion. So let's start. So what is Terraform? So it is an open source infrastructure as a code software tool where you define and create resources using providers in the declarative configuration language, example, JSON. So with Terraform, you can package and reuse the code in the form of modules. So it supports a number of cloud infrastructure providers such as AWS, Azure, Google Cloud Platform, IBM Cloud, etc. Now let's learn about AWS Site-to-Site VPN. So AWS Site-to-Site VPN is a secure way to connect your on-premises network like your office network or data center to your AWS cloud resources. So it's like building a private tunnel through the internet between your office and AWS, which will ensure that your data travels safely and privately. For example, imagine you have a small business with an office network where you store important files and run applications. So you also use AWS cloud services like storage and database. So with AWS site-to-site VPN, you can securely link your office network to AWS. It's like having a virtual extension cord that lets your office network access resources in AWS securely, so just as if they were all in the same physical location. Now let's learn about components of VPN. So components of VPN include like VPN tunnel, virtual private key, customer virtual private gateway, customer gateway, site-to-site VPN connection, VPN configuration. So these are the components of VPN. So VPN tunnel is for securing the pathway for data between locations like a virtual pipeline, example connecting to work from home using VPN. Then the virtual private gateway. So it act like a entry point to cloud network. It manages VPN connection, for example, AWS Virtual Private Gateway for secure connection to VPCs. Then is the customer gateway. So it represents on-premises network in VPN. Endpoint for VPN connection. For example, Office router connecting to AWS via VPN. Then is the site-to-site VPN connection, which will create a secure link between separate networks like virtual bridge, example, site-to-site VPN between Office network and AWS VPC. Then finally comes the VPN configuration, which sets for VPN connection, which include encryption and authentication and routing details. For example, configuring VPN parameters on routers for secure communication. Now let's move forward to the architecture of site-to-site VPN. So this is the architecture of site-to-site VPN where we are using resources like VPC, the public subnet, and etc. So we are using VPC, which is Virtual Private Cloud, a logically isolated network segment within the AWS cloud. So we can create a VPC with multiple subnets. So in this, we have created public subnet and launched a EC2 instance in the Mumbai region. So public subnet is a subnet that has a route to the internet gateway. So instances launched in the public subnet can be accessed from the internet. Then you can find the route table where it determines how traffic is routed within a VPC. So it directs traffic to the appropriate gateway exit point to reach its destination like a map for residents in the VPC to navigate. Then is the VPC gateway. So an internet gateway allows traffic to flow between your VPC and the internet. So a VPN gateway basically enables secure connection between your VPC and your on-premises network. Then is the VPN connection. So it provides a secure tunnel that allows traffic to flow between your VPC and your on-premises network over the internet. So these are the resources which we are going to create by using Terraform. So specifically, the diagram basically showcases a VPC with two public subnets, which is one is the Mumbai region and another is in the North Virginia region. So each subnet has an instance launched within it. So there's also a route table associated with each subnet. So the route table for the public subnet in the Mumbai region is configured to use the VPN connection to route traffic to the internet. So this means that traffic originating from the instance in the Mumbai subnet will traverse the secure VPN tunnel to reach the internet. And the route table for the public subnet in North Virginia region is configured to utilize the internet gateway to route traffic to the internet. So traffic originating from the instance in the North Virginia subnet will use standard internet gateway for internet access. So in essence, the diagram depicts a scenario where VPC resources in different regions are accessing the internet through separate routes, a VPN connection for secured communication, and an internet gateway for standard internet access. So this was the architecture of VPN. So in previous session, we have created AWS site-to-site VPN manually. We have not used Terraform yet. So you can refer this article. So then you can try with Terraform. So this article is available on firsttechniques.com. And you can also refer to the new article which we are currently performing. The practical is to set up AWS site-to-site VPN using Terraform, which is also available on firsttechniques.com. You can refer code as well as Terraform command to apply resources on a AWS account. Now let's move forward and see the steps for setting up AWS site-to-site VPN using Terraform. So if you refer the article, so here you can see the summary view of the Terraform files in the Visual Studio Code. So first, I have created a folder called as Terraform AWS Site-to-Site VPN. So as you can see, this is the folder, and I have simply created two files as we are going to create VPC in both the region. So here you can see I have created one folder called as AP South 1, which will denote the region as Mumbai, and US East one, which would denote the region as North Virginia. Now, simply we need to create files in that region. So let's see the steps. So this is the structure of our summary view of our Terraform files. So our first step is to create provider.tf file for the Mumbai region. So the provider.tf file in Terraform is a configuration file that specifies the cloud provider and its corresponding plugin that Terraform will use to manage resources in that provider. So here we go to our Visual Studio Code editor. So now create provider.tf file. So just select AP South 1 here and create provider.tf file, and then copy the code from the site. So this article is available on posttechnics.com, and paste it in the editor. Save this. So here I have simply created a provider.tf file where we have we are using the provider as AWS, and the region which we are currently using is AP South 1, which is Mumbai, and the profile is set to default where it consists of the access key and secret key to perform the operation on our AWS account. So you need to configure this on a command prompt. Then is the Terraform block where you can see the version, the required provider version. Now our next step is to create the VPC in the Mumbai region. So simply now click on add file, simply type your vpc.tf file. So basically, so the vpc.tf file in Terraform configures Amazon VPC in Mumbai, defining CIDR blocks, public subnet or private subnet, and internet gateway for external access, then route tables and route for the internal bound traffic. So this environment enabled controlled communication within the VPC and with external network. So now we are going to create VPC, then we will create the subnet, public subnet, then the route table. So just copy the code, then just paste here. So first I have created the VPC. So to create VPC, I have taken the resource name as AWS VPC. Then I have mentioned the CIDR block as 10.1.0.0 slash 16. Then I have given the tag name for the VPC, which is AWS Site VPC. Then I have simply created a subnet. So to create subnet, I have taken the resource as AWS subnet. Then I have given the name as public subnet. Then the VPC ID. So the subnet we are going to create the VPC. So here you need to simply mention the VPC name, which is AWS Site VPC dot ID. Then the CIDR block I have mentioned here is 10.1.0.0 slash 24. And the subnet we are going to create in the ability zone in AP South 1E, which is in the Mumbai region. Then the tag name I have given to this subnet is AWS Site AWS Site subnet. Then next we are going to simply create resource named as Internet Gateway to provide the internet access. So simply I have given name as AWS Site IGW, which means Internet Gateway. Then as we need to create the Internet Gateway in the VPC created earlier, so you need to mention here the VPC ID. and simply I have given the tag name as AWS Site IGW, which is Internet Gateway. Next resource as I'm going to create the route table. So I have given the name for the route table as AWS Site Route. So this route table should be created in the VPC created earlier. So I have mentioned the VPC ID here, which is AWS Site VPC. Next, I have, so the final block here, you can see the resource AWS route, internet route, which will provide the route to all traffic destination cider block, which I have mentioned is 0.0, which is of internet gateway. So here you need to mention the gateway ID. This will enable internet access. And at last here you can find the table, and the route table ID is equal to AWS route table. So here you need to mention the route table name, which is AWS site route. And here you can find, so just save this file, and here you can find it depend on the AWS VPC. So basically the depends on attribute ensure that the VPC is created before this route is added, avoiding dependency issues during Terraform execution. So let's check out our next step is to create provider.tf file for North Virginia region. So before that, we will apply this on our AWS account. So simply click on Open Integrated Terminal and first enter Terraform init command to initialize all the provider plugins. Then enter the Terraform plan command to see what are the resources we are going to create. So there are 5 resources which we are going to create now. So just apply this configuration. So just type Terraform apply auto approve, which will automatically give the approve to create the resources. So our apply has been completed and 5 resources has been added successfully. So now just we will verify this. So this is my AWS account, and here you can see this is, so this account have in Mumbai region and another is in the North Virginia region. So just click on VPC here to check whether our VPC have been created or not. So here you can find the default VPC as well as the VPC we have created. So we have successfully created VPC, the subnet, and the route table. Here you can see the route table and also the internet gateway. So in the route table, here you can find we have given the name internet gateway to the route table. Just check another route table and just click on edit rule, add route, and then select internet gateway and the internet gateway name, which is AWS site internet gateway, and select save changes. Now our VPC have been created successfully. So our next step to create provider.tf file in North Virginia region and the VPC. So same as we have performed for the Mumbai region, we are going to same perform for the North Virginia. So let's go back to our Visual Studio Code editor. Now just click on, here you can find a provider.tfn and vpc.tf file in AP South 1. Now as you can see in US East 1, there are 2 files. So just create one called as provider vpc.tf. Enter this and just create another file which is vpc.tf. Now just copy the block of provider in AP South 1 and paste here the US East 1 region. Then simply edit the region which is US East 1. Now we are going to perform the same steps as we have performed in the Mumbai region. So simply you can copy the code from the site which is available on posttechnics.com and simply paste here. So let's check quickly. So first I have take so first as you need to create VPC, I have taken the resource name as VPC and given the name to that VPC as AWS customer VPC. And then I have taken the CIDR block which is set to 10.2.0.0/16 IP. Then simply I have given the name to that VPC as AWS customer VPC. Then the next step, I have created subnet called as AWS customer subnet. Then simply that subnet should be created in that VPC. So simply I have mentioned the VPC ID here and the CIDR block I have taken here as 10.2.0.0/24. The availability zone which we are going to create this subnet is US East 1A. And the tag name, so simply the subnet name is AWS customer subnet. Next, I have simply created internet gateway to provide internet access. So simply take resource name as AWS internet gateway, then the name as AWS customer internet gateway and the VPC. So this internet gateway should be created in the VPC created earlier. Next step is to create the route table. So simply I have taken the resource name as AWS route table. Then I have named it as AWS customer route and the VPC ID where the route table will be created in this VPC. So just check the VPC ID. So this is the AWS customer VPC.id. So replace this with your actual VPC ID. And at last, to provide internet access, I have mentioned here the destination CIDR block to the route. So resource I have taken as AWS route and AWS customer route. And here you simply need to mention your route table ID first, which is AWS customer route.id. Then the destination block should be 00 as this is the internet gateway which will provide internet access. And simply then you need to specify your gateway ID here of internet gateway. And as it is depend on the VPC, simply we have used depends on attribute as previous we have created in Mumbai region. So now simply right click on US East 1, open an integrated terminal. Here you can see two integrated terminal, which is one is of AP South 1 and one is of US East 1. So simply type here Terraform in it to initialize the provider plugins. Now we are going to apply this VPC configuration on an AWS account and verify this by visiting our AWS console. Next, simply type Terraform plan to check what are the resources we are going to create. So 5 resources, which is correct. Now simply type Terraform apply with auto approve. So it will not ask the permission to proceed. So as you can see, it is in creating state. So our VPC have been created successfully. Now just we will verify this in the North Virginia region. So select your VPC. So if you see here, you can find the customer VPC, which we have created with the subnet route tables. So just click on the another route table and edit the route to provide the internet access and select your internet gateway. And select the internet gateway name, which is AWS Customer Internet Gateway, and save the changes. So this will provide the internet access. You can also check the internet gateway we have created successfully. Now let's check the next step. After we have finished the step 4, let's move on forward to step 5, which is to launch Amazon Linux machine in North Virginia region. So as we need to launch EC2 instance in the North Virginia region, we select US East 1, then simply enter the file name, which is ec2.df file, and simply copy the code. So this code will create the EC2 instance in the North Virginia region. So simply paste here and save that file. So here you can find the data source block, which so as you can see, this block uses the AWS SSM parameter data source to fetch the latest Amazon Linux 2, which is AMI, Amazon Machine Image, using the specified SSM parameter name. Next, simply I have created a security group name as customer security group with the ingress rules, which is the inbound rule. So the security group will be created the VPC. So you need to mention here the VPC ID, which we have created earlier in the North Virginia region, which is AWS customer VPC.id. Then you need to specify the name of the security group, which is customer security group, and also the description. You can enter the same details as well. Then you need to enable the port 2022, which is of SSH, which should provide access from anywhere. Next, same is with the TCP from port 0 to port 65,535 with all TCP traffic enabled from anywhere. The next inbound rule is with ICMP to enable from anywhere. Then is the outbound rules, which will allow all the outbound traffic. Now here you need to launch the EC2 instance. So the resource name I have taken here as resource AWS instance, and the name of the instance, which is customer Linux. And in AMI, I have specified the data source which we have created earlier, which will take latest Amazon Linux machine image. You just need to specify this in the AMI. Then here you can find the instance type is t2.micro, which is eligible for free tier account. So I have mentioned your instance type as t2.micro. And the key name, so just create your own key AWS account. So here you can find here is my key. So just type your key name which you have created and just give the tag name so it you will not confuse with as you can see lots of instances created on our AWS account. So anyone can access our instance. So just I have given the name as customer Linux instance to not to get confused. Next is the VPC security group ID, which we have created earlier. Just, just simply enter your AWS security group, the resource name with the customer ID, with the customer security group dot ID, which is the name of the security group created. Then is the subnet ID I have mentioned here, which is AWS customer subnet ID, which we have created in the VPC. Then you should note that This step is compulsory to associate public IP address set to true. So this will give IP address to the instance. So as we need to connect with the instance, then I have simply created an output which will give the public IP address of this instance. So now let's right click on US East 1 now, as I have already created. So just I will apply this configuration. So as you can see, my resources have been creating state. So here you can see two resources we are going to add now. So our apply have been completed, and here you can see our public IP address. So simply copy this IP address. So now we will check on our AWS console that the instance has been created or not. So simply click on EC2. You can also search here, and here you can find that our instance have been created successfully, and we can also see the public IP address of the instance and all other details such as instance type and the key name, etc. Now let's move forward to our next step. Now our next step is to create site-to-site VPN connection in the Mumbai region. So simply create a VPN.tf file in the Mumbai region. VPN.tf file. Close all other files. Select AP South 1 terminal. Now simply copy your configuration from the article which is available on fosstechnics.com and simply paste here. So as we have learned the architecture, we have seen that the VPG gateway, the VPN, site-to-site VPN connection, and the customer gateway should be present in the Mumbai region. So we are going to create these resources in the Mumbai region. So as you can see, the first resource is to create a VPN gateway. So you can see the resource name as AWS VPN gateway. So I have given the name as AWS Site VPN gateway and the tag name as AWS Site VPN gateway, which is in bold letter. And the VPC, so here you need to mention, as we are going to create a gateway associated with the VPC created earlier, which is AWS Site VPC.id. Next step is to create the AWS customer gateway. So the customer gateway in the diagram is shown that it is on the North Virginia region, but it is not like that. You should remember that customer gateway should be created in the Mumbai region. But here you need to specify the IP address of the instance created in the North Virginia region. So go back and copy the IP address and paste here. So this is the IP address of the customer gateway. And the name I have specified here as a customer AWS site gateway. So the BGP ACN is equal to 65,000 and the type I have selected as IPsec.1. So basically, it will specify the border gateway protocol, autonomous system number if using BGP routing, and the type of VPN connection is IPsec.1, which is IPsec tunnel, and with IP address. Next resource I have taken as AWS VPN connection. Then I have given name as I'm going to create a tunnel from Mumbai to North Virginia region. So I can transfer data from the Mumbai region to the North Virginia region. So here you need to simply give the ID of the VPN gateway and customer gateway created earlier. So just give the resource name and the name of your VPN gateway and the customer gateway with .id. Then the type is selected to IPsec1 and select the static routes only to true. And the name of the VPN connection I have given as Mumbai to North Virginia region VPN. Now we will simply apply this configuration. So save this configuration as I have entered the IP. Now we will simply apply this configuration. Now as you can see, three resources to be added. So it will take around 5 to 7 minutes to create an AWS site-to-site connection. So let's wait for some time. So as here you can see our apply has been completed and three resources have been added. So let's verify this. So as you are already in VPC, so in the left hand side corner, if you come down and select customer gateway, you will see that the customer gateway has also been created and in available state. Then if you go down and select site-to-site VPN connection, here if you click on the available site-to-site connection, here you can find that Mumbai to North Virginia VPN have been created successfully. But here you can find the status is down. So now we will perform. So now just download the configuration here. Select your generic. So you need to add some configuration in the EC2 instance to connect with the Mumbai region. So just download the configuration here and open this configuration. So here you can see our configuration file have been downloaded successfully. Now our next step is to enable the route propagation in the Mumbai region. So let's enable the route propagation. So here, if you go up and select route tables, so just select your route propagation and here you can see the virtual private gateway is not enabled. So just click on edit route propagation and select enable and save this setting. So here you can see here you can also see the subnet association routes, and in the routes here you can see the internet gateway is also attached here to enable the internet access. Now our next step, now let's move forward. As we have downloaded the VPN configuration, now we will access EC2 launched in the North Virginia region. So we will access this by using MobX term, or you can also use PuTTY to access the EC2 instance in the North Virginia region. So before that, here I am currently in North Virginia region. Copy the IP address and open the MobX term tool. And select on session, select SSH, remote host. You need to paste your IP address and simply type your EC2 hyphen user. And in advanced SSL setting, just enter your customer key, which is the key pair, and select OK. So here you can see we have connected to the EC2 instance successfully. So we are using LibreSpan, which is an open source implementation of the IPsec Internet Protocol Security suite for Linux-based system. So basically, it provides secure communication over IP network by encrypting and authenticating data packets. So now simply we need to follow some commands to connect. So simply type here sudo su to switch to root user. Now we have successfully switched to root user. So now we need to install the LibreSwan. So click enter. So just type yum install LibreSwan -y. Now our next step is to modify the IPsec dot configuration, which is stored in the etc directory. So simply we need to visit that IPsec dot configuration to check whether the include line is uncommented or not. So simply type your vi to open the editor etc IPsec dot configuration file on, and here you can find below it is uncommented. So just if it is commented, just uncomment it. So click on escape :WQ to exit this file. So basically the IPsec.conf file contains various directives that will define how the system establishes and manages IPsec VPN connection. So our next step is to edit this systemctl.conf file, so which is also stored in the etc directory. So just type here vi etc and systemctl dot conf. So here you need to add to copy this commands. You can also refer the command from my article. So if you go below down, so copy this net IPv4 forward and paste here below. So just click on I to insert and then click on enter, backspace, and so basically the net IPv4 forward is equal to 1. We set the kernel parameter to the value 1. So in simpler terms, it enables IP forwarding on a system. And yeah, all except redirects net IPv4 will configure settings for all network interfaces. So now just escape this. Now our next step is to restart the network service. So simply type system ctl restart the network settings. So system hyphen network. So as you can see, there is no service found here. So you need to install that service. Now simply click here. Y means yes. Now just select the above command and we have successfully restarted the network. Now next we need to edit or create the ipsec.t and add the VPN configuration. So we need to add our VPN configuration. So simply type your vi etc. So all the configuration are stored in etc directory, and here you need to type your ipsec.d and create file named as aws-vpn.conf. So this will open the editor. So as you can see, it is blank. So simply you need to copy the code, the configuration from the article and paste here. Now, previously we have downloaded the site-to-site VPN configuration. So here you can see the configuration file. So simply go down and just copy the IP address of customer gateway and replace it with the left ID. So type here I to insert the IP address. So backspace the existing IP address. Now same, so left ID denote the customer gateway and right will denote the virtual gateway. So simply copy this and paste it. So all other configuration is correct. You also need to add here left subnet, which is now correct, but you need to add left subnet and the right subnet. So now click on escape :WQ. So this will save our AWS VPN configuration file. So our next step is to create the AWS-VPN.secret. So as this file will store the pre-shared keys used to authenticate your system with AWS VPN gateway while establishing IPsec tunnel connection. So that's why we need to create AWS VPN secret file. So just we will replace the AWS VPN to AWS secret file. So just type AWS-VPN.secret and click on enter. So now, so here you can find that first you need to enter the customer public IP, then the virtual private gateway IP, then PSK with the shared secret. So pre-shared secret. So simply copy this and paste here. Now open. So simply copy the customer gateway IP address. Click on I. And then right click, which will paste the IP address of customer gateway. Now simply enter here the IP address of virtual private gateway. Now, so the line which here you can see in the double quotes is the pre-shared key. Now simply go up here and you can find your pre-shared key. So just copy this and paste in the double quote and just save this file now. Escape :W. Now our next step is to enter the command to start the IPsec server. So simply type here chk config IPsec on. So this command will enable the IPsec service to automatically start. So we have started the IPsec. Now next is to type the service IPsec start command. So basically the IPsec start command will allow to manage our VPN connection. So as you can see, Now just we will check the status of our tunnel. So as you can see, our status have been actively running, and here you can see the tunnel is initiating state. So our tunnel 1 has been actively running. So let's check this on our AWS console. So if you go down here in virtual private network, select site-to-site VPN, and here select the available site-to-site connection as we have created from Mumbai to North Virginia VPN. And as you here you can see the status is down currently. So refresh this. So after you will refresh around 3 times here, you can see the status is up for the tunnel 1. So tunnel 2 is basically for if the tunnel 1 is failed. So that's why it is, so tunnel 2 can be used. So as you can see, we have successfully created site-to-site VPN connection from Mumbai to North Virginia region. So now our last step is to delete all the resources created. So simply type Terraform destroy command to delete all the resources. So simply clear this and type your Terraform destroy and type auto approve to proceed with the. Now select another terminal and simply type your Terraform destroy auto approve. So all the resources will be deleted. So you can also check the previous article where I have done all the steps manually on our AWS console. You can also refer this article which is available on posttechnic.com. So after deleting our resources, we will conclude for today. So in conclusion, utilizing Terraform for AWS site-to-site VPN setup streamlines network security and connectivity, ensuring seamless encrypted data transfer between on-premises and AWS environments with ease and scalability. So thank you for watching my video, and please do like and share the video, and don't forget to subscribe my channel. And thank you again, and see you in the next video.